Looking at the immense scale and stability of our universe, a specific puzzle emerges. A universe governed by a single unified force is mathematically possible, yet physical reality relies on exactly four. The standard approach in particle physics focuses on the math. The standard model explains the mechanics of these interactions with extreme precision, but it treats the specific number of forces as a structural accident. Finite distinction systems, specifically paper X3 from the FDS core, approaches the problem from a different angle. It replaces the search for mathematical derivations with a functional taxonomy. The core thesis is straightforward. For any physical world to maintain distinct, persisting objects, whether that's a rock or a star, it has to fulfill four specific operational jobs. This diagram is a four-quadrant map of those required jobs. When we look at the requirements, the four known fundamental forces align directly with the operational needs of the universe. These forces are the minimal operational toolkit required to keep a physical reality from collapsing. We can test this functional necessity using a subtraction protocol. By running a thought experiment where we delete one operational class entirely, we can see exactly how the universe breaks down. The first required job is encapsulation. A physical system needs a mechanism to bind raw possibility and energy into stable, persistent physical tokens. Nature's implementation of the encapsulation job is the strong nuclear force. If we remove the strong force, ordinary matter loses its cohesion. Particles violently dissolve into an unaddressable, formless soup. Assuming you have stable matter, the second required job is connection. Distinct objects need a way to detect each other across distances, form chemical bonds, and communicate structurally. Electromagnetism executes the connection job. Switch off electromagnetism, and the protected tokens survive, but they become completely blind. They cease communicating entirely, left to drift in a pitch-black void. A universe requires both encapsulation and connection to produce interactable matter. The third job is identity update. Physical systems require controlled transformations over time, including decay and shifts in their internal flavor states. The weak interaction provides this selective update and decay channel. Erase the weak force and the universe freezes solid. Matter remains connected but is permanently locked in its identity, unable to undergo change or decay. The fourth and final job is global causal-ledger geometry. This forces local interactions to obey shared causal boundaries and global resource limits. Gravity implements this global causal screen ledger. If gravity tears apart, processes lose their shared spacetime structure. The result is isolated, uncoordinated fragments floating independently, with no global accounting tying them together. While these four forces participate in a wide variety of physical processes, each supplies one primary operation that the other three cannot naturally replace. Failing to fulfill any one of these operational pillars leaves a finite system unable to maintain its boundaries. This strict categorization raises a valid challenge. How does this balanced four-box framework survive the potential discovery of dark matter or a new fifth force? Discovering a new particle does not automatically falsify the FDS operation closure thesis. This fifth force audit tree tests if a discovery performs a new job. A particle merely mediating interactions routes into the connection pathway, a new worker in an existing department. The framework fails only if a force implements an irreducible operation outside the original four requirements. The FDS audit shifts the focus from uncovering new equations to identifying the irreducible jobs nature requires to persist.